Hi, this is Professor Guyad with Middlesex College, and today we're going to be talking about linked lists. So the idea of a linked list is it's a list that's comprised of nodes, and each node has a value. So that value can be a string, and any data type, an integer, a char, any of the data types we've covered so far. So that node has a value and it has a pointer to the next node in the list. This is a singly linked list that we're going to be talking about today. A doubly linked list would have a pointer to the previous node as well, but we're just dealing with singly linked lists where there's a value and a pointer to the next node in the list. The tail of the list should point to null because the tail is the last node in the list, and so it shouldn't point to anything else. It's not connected to the front, to the head of the list, like a doubly linked list would be. So in a singly linked list, the tail points to null. So let's take a look at an image of a linked list before we jump into our IDE or Eclipse and start coding it. So let me share my screen. Here you can see the singly linked list. So we have node 1, which is the head, and it has a value of 7. And then the other attribute it has is a pointer to node 2, the next node in the list. So as you can see, node 1 right here, node 1 dot next is going to be 6 because node 1 points to node 2 and node two's value is 6. If you did node 1 dot val or node 1 dot element, whatever the name of the attribute that displays the value of the node, if you did node 1 dot val, it would say 7. Node 1 dot next is 6. And then we look at we look at the list as a whole, and if we were to do link list dot head, that would be 7, right? Or link list dot head dot val would be 7. Link list dot tail dot val is 2 because node 3 is clearly the tail in this list and its value is 2. And if we did node 3 dot next, as I said previously, since node 3 is the tail, the pointer to the next value for the tail is null, right? There's nothing that the node 3 is pointing to. So this gives us a nice idea of the linked list data structure. Now let's look at it in Eclipse in an IDE. So in Java, we have two classes. We have the node, the linked list node. That's what the LL stands for, linked list node. And like I said, we're just going to deal with an integer linked list to make it simple. And it's going to have a val, right? A value that's stored in the current node. And it's going to have that pointer to the next node. See how the data type is the class itself, right? The node points to another node, and we're going to call that the next node. Great. And then it has a constructor that takes in the value and the pointer to the next node. Now let's implement the linked list and see some common methods with the linked list. So the linked list itself, the entire structure has a head and a tail, which are both, these are attributes, right? Which are both linked list nodes. The head and the tail are nodes, and it has a size, which starts at 0. And we'll just leave the constructor empty for now because we're going to be building a linked list based on nodes. We have getters for, and I also have to mention that this linked list class that I created, my linked list, is a subclass of the linked list class, superclass that exists already in Java. So, sorry, I saw okay. So we have a blank constructor, then we go into the getters. So get first is going to, the return type is going to be the node, right? Because the first element in the linked list is a node. That's why the return type is linked list node. If the size of the linked list is 0, then we return null, right? There's nothing to return. Else, if the size is positive, then return the head because we're getting just the first node in the list. Great. We have another getter get last. Similar idea. If the size is 0, there's no nodes in the list, so we return null. Else, return the tail. Get the last element. The tail is the last element. And we have clear, which is going to just clear out the entire list. So we set the size to be 0, and we set the head to be null and the tail to be null. Pretty straightforward. Then we get into a few complicated methods. We're going to cover a couple of them. So add first. So if we want to add to the beginning of the list, this is how we would do it. We pass in some integer so that we can assign a node to have that value of the integer. So the first line of the add first is we're creating a new linked list node. We're assigning it to have the value of the number passed in, the integer passed in, and we're setting the next node to be null because we don't know if this list will have more than one node. So we set it to be null. New node dot next node is set to be the head, right? Because we're adding the new node to be the head, hence the term add first. So the new node's next node should be head, and then the head points to the new node, right? So the head should be the value of the new node. And then, of course, we increase the size by 1 because we've just added one new node. And then we cover all of our tracks, we cover all of our bases by saying that the new node, if the new node is the only node in the list, in other words, if the tail is null, if there's just one node, then the tail should be set to be the value of the head. They should be one and the same. The tail and the head should be one and the same if the linked list just has one node in it, which is to say if the tail is null, right? So then when we added the first node and the tail is null, then that means we only have one node in the list and the tail and the head can be one and the same. Great. So that's how we add first. We add a new element to the beginning of a linked list, whether it has no nodes in it or some nodes in it, either way. Then we want to explore these methods eventually that will probably be assigned as homework. Add last, so add to the end of the linked list, and add in general, add to some specified index in the list, which you could imagine in terms of time complexity, big O notation, that adding at some index in the list would probably be more time consuming than adding to the beginning and adding to the end of the list. Now let's look at a similarly complex method as add first, maybe a little bit more complex. We're going to do remove first. So remove first returns some element, right? And we have this generic object, whether it be an integer, string, number, null, something like that. So when we remove first, if the size is already 0, then you can't return anything, right? There's nothing to return. So we return null. Else, if there is at least one element in the list, then here's what we're going to do. We're going to create a temporary node, linked list node, that stores the value of the head. Then we're going to set the head to be the value of the next node, right? Because we stored the head in temp, and because we're removing the first node, the head, we need to store the value of the new head to be the value that once was the next node, the node to the right, if you will, of the head. And then we decrease the size by 1, of course, because we're removing one element. And then we do, if the head is null, then that means that if the element we just removed made the value of made the size of the linked list to be 0, then we should set the tail to be null. The list has become empty, so we want to destroy the tail. And then we can return the value of the previous head. We can return that value because we're removing it from the list. So that's how that goes. And then remove last is another common method of the linked list class that you'll want to study and implement on your own in preparation for an assignment, a homework, a quiz, or the final exam. Then we implement it in the main method. So we create a list. Excuse me, I didn't need to create these. Then we add first, and the value of the node is 1. And remember that in add first, we're creating a node within add first. So we don't need to create nodes out in main because add first automatically creates the node with a value of 1 and a pointer to null. So then we print let me comment these out. We print the value of the head, right, of the list, and it should be 1, right, because we added 1 to the list. So let's see that. And we see that it is 1. Yep. Then let's comment out more lines. We add 22 to be the head now. So 22 should now be the head. And so now when I print out the head, it should be 22. And when I print out the tail, as you can see here, it should be 1. So what should print now is 22 and then 1. Let's see that happen. Yep. The head is 22 because we added first, and then the tail is 1. Beautiful. Then we remove first, so 22 should be removed. And the head should be 1 again. And we should see 1 printing here. Beautiful. Okay. So I've used the methods that I created above, add first and remove first, and they worked very well. And these were the way they were written in the textbook, and you can definitely alter this code to make it work for you as long as it does what it's supposed to do within the confines of how a linked list is constructed and the rules according to a linked list as defined by many computer scientists, right? So this was a lecture on linked lists and a pretty complex data type that we're going to want to learn more about. And thank you for viewing, and I'll see you in the next video.